Hi all, and welcome to the webinar, Big Data Analytics Stories with Hadoop. I'm Teresa and I have John Ryan from Actian here with me, and we have a great demo-based presentation exploring 2 customer stories for you today. And we're going to take you on a storyboard journey of big data analytics, starting from how data is stored in Hadoop all the way through to dashboard presentation of that. So today's presentation is by both Actian and Yellowfin. Why are we presenting on big data analytics? Well, Actian is one of the leaders in the big data analytics space, and their Actian Analytic platform powers many of the world's biggest big data analytics implementations. From Yahoo, leading retailers, financial institutions and telco providers, all the way through to Amazon Redshift, which is basically a cut-down OEM version of Actian Analytics platform. And Yellowfin is a global business intelligence software vendor passionate about making business intelligence easy. We offer a fresh approach to BI focused on empowering the widest audience with the ability to consume, analyze and act on data. Yellowfin's market-leading features include mobile BI, collaborative BI and locational intelligence. And key clients include Telstra, Vodafone, Census, Commonwealth Bank, Macquarie and Wollongong universities. So why Actian and Yellowfin? Actian have the fastest technology for big data analytics, which includes the fastest single node and multi-node databases, which are 50 to 100 times faster than traditional systems, the fastest SQL and Hadoop engine, which is 10 to 30 times faster than Cloudera Impala, and the fastest Hadoop processing engine, which is 10 to 50 times faster than MapReduce. And it also includes a huge library of analytical functions. And as you'll see today, it makes Hadoop easy to use with user-friendly drag-and-drop operators. And when it comes to Yellowfin, we've been recognized as a top-performing enterprise dashboard and ad hoc analysis vendor in BARC's the BI Survey 13, the first in Dresner Advisory Service 2013's Wisdom of Crowds BI Market Study for the 2nd year in a row now, and in Gartner's Magic Quadrant for 2014 for the Business Intelligence and Analytic Platforms. So now I'm going to pass over to John.
Thanks, Teresa. So there is a big shift underway in the BI and analytics space. The digital floodgates have been opened and they will never ever be turned off again. Big data tools are getting more and more mature, and as a result we're seeing an exponential growth in the data that's being captured and stored. It took Walmart over 10 years to generate 100 terabytes of data, and Yahoo now does that in a day. In addition, we have a much larger variety of data types that we can do analytics with. Machine data, social data, the Internet of Things, mobile devices and their apps. And these new data types are driving new types of analytics, like geospatial analysis, sentiment analysis and network graphs. And winning organisations do a lot more than just manage this volume and variety. They use analytics to deliver faster time to value. Winning companies understand the value of being first, and they understand the value of being able to change and adapt quickly, because time is the new gold standard. However, big data analytics is still in its infancy, though it is maturing rapidly. About 88% of the data that has been captured so far has never been analysed, and McKinsey estimates that hidden within that data is the ability to generate an additional $15 trillion of value. So big data represents a huge opportunity. However, there's only about 1% of companies that have figured out how to leverage that. And it turns out that that 1% of companies are using a very different set of tools than the other 99%. Instead of using databases that struggle with scale, they're using new big data tools such as Hadoop and big data analytics platforms like Actian, which we're going to show you in today's presentation. And studies like this one from McKinsey show that companies that are leveraging big data and are using it strategically are outperforming their competitors and winning in the marketplace. And this chart here shows a staggering performance difference between analytics-driven companies and those that are not doing big data. In many cases, they're just completely destroying traditional business models. For example, when was the last time you picked up a Yellow Pages? You don't, you just Google it now. And big bookstores like Borders and Barnes & Nobles are being completely put out of business by tech startups such as Amazon. And who here remembers when Amazon was just a bookstore? Companies that are using data strategically have a competitive advantage, and in fact it's actually a sustainable competitive advantage. So before an organisation can become analytics enabled, they do need to go through the journey to best-in-class analytics. And today's demonstration, we're going to take you through this journey. Many of our customers are in this dynamic or analytics-enabled space. However, when we talk to a lot of customers and prospects, they're very open and honest, and most companies are actually down here, sort of in that static area where they're able to do their reporting and maybe have some drill down, but they're struggling to go to the next step and be able to do more reactive or monitoring and alerts of their data in real time. And to get from here to here really does require a different class of technology on the back end. And then in order to make the jump from reactive to proactive, again there's another set of technologies that you need to do things differently with. And then finally being able to take all of these new business processes and roll that into how your business does, how your business works is really what we want to show you today. So we're going to take you on that demonstration. Because ultimately it's all about turning data into transformational value. And really what can be created when you can connect to any data source quickly, and when you can cleanse and transform and merge and process that data quickly, and when you can analyze it and be able to build predictive models that can execute and run very quickly, and ultimately, you know, be able to create that transformational value which is around customer delight and competitive advantage in these disruptive new business models. So I'm going to hand back now to Teresa, who's going to give you an introduction into today's case study.
Okay, so today we have two demonstrations in the telecommunications space, including core routing network analysis and customer churn. And our demonstration will take you on a journey from data to dashboard. What were the initial business requirements that we had here? Now, this story starts off like every other big data analytics story. The business wanted faster time to decisions. So they wanted to get their answers in seconds rather than waiting hours or possibly days to process and analyze. They also wanted more granular reports. Many of their most pressing business questions that simply couldn't be answered because they weren't able to analyze their data at a granular enough level. So they really needed to address how much information they could access. And finally, they wanted to do something that would be scalable. They knew that their business was going to grow and they wanted a solution to grow with it rather than having to be replaced in a few years. And this was really important because they knew that they eventually wanted to be in a position to collect and analyze all of their data. So next, what were the IT challenges? Now, from an IT perspective, they were swamped with data. They initially wanted to analyze call detail records or CDR log files, which are basically logs of all the machine-generated information about the calls that we make. They were collecting about 100 megabytes per switch per minute, and in the past this data had not been properly analysed. From here, the Hadoop distributed file system, or HDFS, was chosen as the engine to collect, manage and process these CDR log files. And they chose Hadoop because the data was too big and would have been too expensive to store inside a traditional relational database. So the next challenge was that the analysts were domain users, but they were not data scientists. So they knew their data, but they didn't understand how to get exactly what they wanted out of it. So the last challenge was that as a result, they were finding it really difficult to analyze. So for example, it would take them days to find out that 6 out of 7 of their routing attempts were actually failing, but then they were unable to drill down and actually investigate where the call routing was failing and then act on that. Another example is that each log file contained how each call was routed through the network. However, each log was stored as a row, and therefore the routing attempts were stored in different columns. So in order for them to be able to drill down, they needed to transform that into a different format, and we'll go into that in a minute.
Thanks, Teresa. So with this demo, it's all about going from the data in Hadoop to the dashboard. So let's get started. So what you see here is our HDFS or Hadoop distributed file system interface. And for this particular instance that we host, we have about 106 terabyte capacity, and we're using about 68 terabytes of that capacity, and this is a 5-node cluster that we're running on. So one thing about Hadoop is that it is a file system, it's not a database. So we're going to browse and show you what our data looks like beforehand. So this is where we keep our CDR data. And so basically what happens is every minute about 100 megabytes of call detail records dumped into these folders here. So it starts off on the staging folder, and then every 20 or so seconds we actually need to process that data. So Teresa mentioned before, the data wasn't really in a usable format, so this is where we transform that data and make it usable. And once we've transformed it, we keep that there in the storage layer. So I'm just going to show you an example here in the folder small. It's the demo folder. And if I open up one of these log files, you can see it's not very user-friendly, but inside this there's about 170 different columns per row in this data. And that includes everything from what was the destination number, what was the origin number, what was the time, as well as the routing path of how one phone connected to another going through their network. So there's a lot of data there, but in this really text file format, it's very hard for an analyst to be able to do much with. So what we do to make that easy, because we're all about making it fast and easy, is I'm going to go into this is part of the Actian Analytics platform. So this is Actian Data Flow, and what you see here is our workflow that we've built. So just before I go through this, just a little bit, what is Actian Data Flow? So it is a massively parallel ETL tool which also is able to process analytics. So it does everything super fast in parallel, and it was really designed from the ground up to be able to work with Hadoop and then connect your data inside Hadoop to other systems as well. Another way to think about it is that it's a great replacement for MapReduce. You don't have to do any programming at all. It's just drag and drop operators, which are highly configurable. So no coding, and it also is between 10 to 50 times faster than MapReduce as well. So just a little bit about this specific workflow. So the first thing that we're going to do is we're going to connect to our data inside Hadoop. So I'm just going to open up this operator. And you can see here we're browsing that same file that I showed you before with our data inside Hadoop. So we are browsing this natively. And we do get a preview of what this data looks like. So our analyst is able to go in there and sort of get a much better understanding of the data that's actually in there. If any of these data types are wrong, it's very easy. Everything's highly configurable for them to go in and change the data type. And for this particular data processing that we're going to do, we only need to work on about 15 out of that 170 columns. So we're only going to select the data that is necessary for our analysis. So this is how we connect to our data inside Hadoop. This is a text reader. If we wanted to read from another database, we can just drop a database reader. So again, it's very highly configurable. So for this analysis, we've now connected to our data. We're going to filter out our calls. So these are call logs that have not yet been completed because they're not going to be very useful for our analysis. So we're going to filter those out. Our telecom provider wanted to analyze this data in 15-minute time buckets because that was their standard. So we're going to do that data processing before we do our analysis because it's going to be a lot faster. And Teresa mentioned that they were unable to analyze where the calls were failing to route successfully. So we're going to add in some location data. And to do that, we're just going to filter out our calls between international and domestic calls. So for international calls, we're going to add in the country code. For domestic calls, we're going to add in, using the exchange, we're going to add in the area code as well as the state details. we're going to union that together, calculate post-dial delay. So this is a telecom metric for how long it takes for the call to successfully start ringing. So if you call your friend overseas and it takes 15 seconds for that call to connect, that would be a 15-second post-dial delay. So we're going to pre-calculate that. And Teresa mentioned that they were unable to drill down into how the calls were routed because each entry was on a single row, so therefore the routing paths were on individual columns. So this operator here is it will pivot those columns where the routing attempts are and turn them into rows. So that's going to give us the ability to drill down and find out some rich information. So we're just going to finish with a little bit of cleanup and then load that into one of our high-performance analytic databases. So this was our workflow. So now that the data is actually inside our database, we're able to analyze that. So I'm going to pass it back now to Teresa, who's going to take you through what we're able to find.
Okay, so what we see here is a high-level summary report that we're having a look at our call detail records. And we're actually exploring these by day. So you'll notice in this line chart here that each hill represents a week, and the dips are naturally the weekend where there are far less calls made. And the lowest point, so over here we have a dip that's out of the norm. This is over the Christmas period when everything goes quite quiet. Another thing we've been able to identify is that in order to connect 1 billion calls, we've actually had to go through 7 billion routing attempts. And so basically this is just identifying how badly the routing attempts are going. And a lot of those attempts were failing, and basically they didn't know why. So what we've done is create some reports that give us a little bit more insight into that. So initially we created a routing performance by area code map. So what we did was display the area codes that are performing really badly, so 30% or lower answer service rate. And we actually color-coded the pins to identify which is the worst performing out of that bracket. And if I zoom into Virginia, you'll see this red pin is the worst. So if I click on that, I'll get a little bit more information. And what I can see is I've got 29,000 routing attempts, and I've only actually made 2,900 connections. So that's not a very good stat. And what we can do from here is actually toggle to a tabular view of my report and then drill further into more information. So if I click on an area code, I can now investigate the routing vendors I have within that area code. So the first thing we'll have a look at is the position or the priority we give to each vendor. So this priority 1, so this is generally the vendor that we go to first, is only actually connecting 4% of the calls. But if I compare this to a vendor at 4.5 average position, they're actually connecting over 5 times the amount of calls. So clearly our routing table, our priorities are a little out. So we'd need to adjust those. And we could do that with this data. Secondly, we can actually identify that at least one of our routing vendors may have a hardware issue. So especially this top vendor here, they've made nearly 2,000 routing attempts, but they've only actually made 3 connections. And this is data that our routing vendor and our telecommunication provider didn't have access to before. So what we've done is allow them to access this. And we've done this through our routing vendor performance portal, which is an external facing analytics portal. And basically it's designed to monitor the performance of each individual vendor. So what we can see here, using our 15-minute time buckets that we added in our process earlier, we can see the number of calls that have been connected. And we can also see how many calls we're trying to send through from the telco's end. So what we notice is this particular vendor actually has a capacity limit over here. So we never actually connect more than approximately 360,000. But our telco is still trying to send through over 1 million calls at that stage. So this is probably something that both could address. We could look at why we have a capacity limit here as the routing vendor, But as the telco, we could look into perhaps funneling off some of those calls to a different area. And from here, we actually created an alert system. So what we've done is monitored each routing vendor, and when their performance drops below that 30% threshold that we were looking at earlier, we actually notify both parties. And this just gives them the opportunity to A, fix any possible issues on the routing side of things, but also gives the telco the opportunity to perhaps reroute to a different vendor, changing their table.
So just want to give you a bit of a summary of some of the results from this solution, because all of those reports that we were showing you before, they were literally unable to do. So with the first week of collecting this data, a telecom provider actually made 20,000 updates to their routing tables. And as a result of that, they found that the CPU utilization at the switch actually halved. So what that means is that they now have the capacity to connect more calls than they were before, and when you connect more calls, you can make more money. Another benefit was that calls were being connected faster, and there were also less dropouts as well. And this is a great metric for customer satisfaction. They're now able to do much deeper analysis with visibility at the area code and the exchange level. By doing this, they can now see which vendors are actually performing better than others, and it gives them the ability to better negotiate with those vendors to get the best price, because not every vendor gets the same amount of money for connecting calls, and also not just the best price, but also the best service for their customers. In terms of actionable insights, they're now able to do things a lot faster. They're getting alerts, the data's updating in near real time, and this means that they can deal with issues as they happen. They don't have to wait for days or weeks to find out what went wrong. And in the first 6 months that we worked with this customer, they were able to collect 8.9 billion records. So that's a lot of data, and this is a very rich data set to be able to do things such as trend analysis and predictive modeling, which we're going to show you in our next demonstration. But look, the key point for this is that the solution that was delivered, it's scalable and it is future-proof. Every component of the analytic pipeline is scalable, from how you're collecting the data inside of Hadoop, and they're not going to come into any issues on how much they can store, to how they're processing that data. So they can process as much data as fast as they need to with the Actian Analytics platform, as well as analyze that data as well. So again, if you need more performance, you can just add another node and be able to get that. And of course, Yellowfin plays a big part of this as well. Yellowfin is one of the most scalable, not the most scalable business intelligence tool out there. They have solutions that are running with hundreds of thousands of users, and many other BI tools really do reach a scalability limit at around that 100 mark. And this is great, particularly if you're going to be deploying anything like mobile BI and giving a whole heap of vendors and partners good access as well. So it means that you can deploy and scale it out to everyone. It's BI for everyone. Okay, so that was the first part of our demonstration. That was really going from static reporting to reactive reporting. The next part is where we're getting proactive, and we're going to be doing our predictive analytics. So this demonstration here is around customer churn. Churn for telecommunications provider is a really, really important metric. Just to give you a little bit of insight for those that aren't in the telco space, the figures that we hear is that it costs about $500 to acquire a new customer, yet it only costs about 1/5 of that amount to retain an existing customer. So it's quite a big difference, and the telco, particularly in the mobile space, is highly oversubscribed. In most of the Western countries that we deal with, there'd be somewhere between 1.3 to over 2 phones per person. So, and there's also a lot of competition that's out there as well. So it's a very important metric, and if we can improve telecommunications churn by even 1%, that could mean tens of millions of dollars to the bottom line for our telecommunications providers. So this is really what traditional churn analytics looks like. We haven't invented this. This has been around for a while. And what it does is that it looks at the CRM database, which really contains your billing information and demographics about your customers. And what they'll do with traditional churn analysis is they'll take a sample of the data, so maybe 1,500 people or 5,000 people, and they'll build some models and work out what all the relationships are, and then try to apply those models to the other customers that are out there. It's kind of like an election poll, might be a good way to describe it. And really what we can find out from this, because of the data that we're looking at, is people who are not under contract are more likely to churn, or how long that they've been with the telecommunications provider, what their bill is, and their age and sex. However, it's telling us who might churn, but it's not telling us why they'll churn, what's actually causing an individual to churn. And as a result, traditional churn analysis is actually only about 5% accurate. So how do we increase that? And the great thing about big data, particularly when we apply it to predictive modeling, is that the more sources of relevant data and the more data that you have, the more accurately you will be able to predict what's going to happen next. So we can see that when we actually add device data to our models, our ability to identify churn increases from 5% to 40%. And by device data, this is what type of handset they're using, what's their data plan, how much usage do they use of that data plan. And this makes a lot of sense because if you've been with a telecommunications provider, maybe your contract's up, and your friend gets a new phone and they're on a better plan than you, why wouldn't you leave to join the same plan as them? So this is actually a reason why people leave. We're going to continue to add more sources of data, so we're going to add those CDR log files that we showed you in the first demonstration. So inside of those log files also contains information about every time a call has been dropped. And this is, again, a very important reason why somebody might leave a telecommunications provider, because if you can't get proper reception at your home or at your office or where the places where you might need to travel to work are, then you're going to leave that telecom provider. And you can see when we add this additional source of data, our ability to to identify who's likely to churn increases to 50%. And then we're also going to add location data. So I'm in Australia, and if you're in, I guess, the outback or the non-cities in Australia, there's really only one provider that everyone knows can be able to connect you. So if you're in those regions, you're less likely to churn than if you're in a city where there's a lot of other good offers and you can get a much better price with a different vendor. So location makes a big difference as well. So you can see as we add more and more data sources, our ability to identify churn actually increases. So this is a high level what the model looks like. Inside the Actian Analytics platform, what does this look like? So we mentioned before we started with our CRM database, and again we're just using a simple drag and drop operator to connect to the database. And our other data sources in this case happen to be stored inside of Hadoop. So this includes area code data, the device data, how many times their calls have dropped, as well as the service calls as well. So this will track how many times they might call into the telecom provider, possibly to complain that their calls have dropped. So all we do is we're going to place the data that we want to access, we're going to join those together, do a little bit of data prep, and then in order to build our model, what we're going to do is it's known as a 70-30 split. So for 70% of our data, we're going to put that into a learning or a learner logistic regression. And what this is going to do, it's going to go and sort through all of the data and find out what the correlations are and build our predictive model for us. So these are highly configurable operators. So particularly if you've got a statistician, they'll be able to pretty much do anything that they want to optimize these. And then for the non-statisticians, so I guess more of the analysts or the business users, if they wanted to rerun these or drop these on other sources of data, they can just reuse what's already been done. So we've built our model with 70% of the data, and now we're going to test our model with the remaining 30% of the data. So when we're talking before about our accuracy of how much we actually identified who was going to leave based on those correlations, this is where we got these results from. So in terms of what this looks like, I'm going to hand back to Teresa, who will show you what some of these predictive dashboards can look like.
So using some of that data that we just added in, we're going to start exploring our customers. So the first thing that we're going to have a look at is where our customers are likely to leave from. So what we did was plotted that information on a map, which makes it really easy to visualize what areas we need to focus on. So we've got a couple of really large bubbles here that are pinpointing a large cluster of customers predicted to leave. So what we would need to do is explore those areas and find out why they're going to leave and what we can do to address that. Next, we have a look at when customers are likely to leave. So this chart really clearly depicts what's happening within and outside of a contract period. So you'll see the first 24 months, which is a standard contract at the moment. Customers are really very unlikely to leave. We'll have an occasional customer here and there that might leave. The majority will stay throughout their contract period, and then as soon as that period is up, we spike straight up for the next 6 months. And then that slowly drops off. So we have our long-term customers that stay for quite a while. But what we need to think about here is addressing our customers before their contract period is over so that we can try and keep them on for another contract period. And we have a little bit more insight into that as well. So the next item we'll have a look at is why customers churn, so why they're leaving. And the first thing we have a look at in this space is usage. So one of the ways we look at that is how much they're actually spending per month, so we can identify which billing groups may be most likely to churn. From there, we'll have a look at how many calls they're making and also how much data they're using. So all of these are very important. Next, we're going to have a look at our customers by device and try and identify if there are device relationships to customers leaving. So initially, we've had a look at those by manufacturer, and what you can see here is we have a large proportion leaving with Apple devices. Part of the reason for this is the data that we're looking at the moment is US-based, and a large proportion of the market is actually Apple products. But that doesn't mean we shouldn't concentrate on those Apple customers. So what we've done is actually split that up further and investigated a few different branches of that. So the first is the actual device rather than the manufacturer. And what we can see here is the older the device, the more likely they are to leave. So we've got quite an old iPhone here, an iPhone 3G, some old Motorola's, and as we progress down the graph and customers are less likely to leave, the devices are getting newer. So we can see from that we maybe need to address our customers that have older devices. We've also split this information up into different operating systems so we can see preferences and perhaps change in preference here. And finally, device color. And then we examine one of the biggest issues when it comes to customers leaving. This particular chart is examining those dropped calls that we had from our CDR log files. So what we're looking at is the number of dropped calls compared to the number of times our customers are actually calling customer service to address any issues that they're experiencing. And what we can really clearly identify here is the customers that experience between 10 and 15 dropped calls per monthly billing cycle are far more likely to leave than anyone else. And if they've not called customer service, they're basically walking out the door. But if they call customer service at least once, we tend to be able to retain that customer. So we solve their solution, we provide them with alternatives and things like that. Now, in order to delve a little bit deeper into this issue, we've investigated dropped calls by device. Okay, so what we can see here is, again, we're just confirming what we thought before, that older devices actually have a higher number of dropped calls and then a higher number of customers leaving based on that. So what we can really identify is that the older the device, the more we need to pay attention to the customer and perhaps preemptively offer them newer devices or contact them.
Thanks, Teresa. So just to recap some of the results for this and how this really helped them change the way that they were doing business. So their ability to identify which customers were going to leave jumped from 5% to 70%. And it did that because we're not just looking at more sources of data, but we're looking at all of the data as well. And as a result of looking at all of the data, we're able to get down really to that segment of one analysis, so where we can pinpoint and exact customers, what their risks are and what's going on in their life. This is not possible when you do your modelling based on samples. You have to do it on all of the data. And how this gets applied in terms of a better inbound experience is our customer service representatives can get access to this data, as well as we can build in recommendation systems which are going to be able to recommend the best offer if the customer happens to come in. It's not just demographic data. We're able to be told who's got the older phone, what offer we should make. In terms of more effective outbound campaigns, and this is one thing Teresa showed really well, if their calls are dropping out between 10 and 15 times, they're a super hot area, and we know that it's because they're using the older phones. And those older phones, anything below the Apple 5 does not do 4G or 4GL network access. So we're able to target those specific customers with the older phones. We can call them up, we can apologise for having so many call drops and let them know, look, we think the reason for this is because you're using one of the older version phones, you happen to live in a valley. If we provide you with the latest phone, you'll experience a much better reception. So how does that sound? How about we lock you in for another 24 months? So the telecommunications provider is able to keep these customers happy, keep them locked in. They can target them 1 to 3 months before their contract expires, before the competition comes out to them, and it can be a highly effective campaign. And on top of that, there's also we're not just keeping the customers happy that had experienced negative issues. What we're able to do is find specific segments inside our customer base and really delight those customers. So an example of this is they're able to work out that their highest spending customers, the ones that would literally spend thousands of dollars a month on their contract, happen to also be technology junkies. So these were the customers that would do a lot of travel, and they always wanted the latest phone with the biggest screen or the lightest one with the best battery life. And so these specific customers wanted to upgrade their phones every 3 to 6 months. And because of the value that they add to in terms of how much they're spending, and also generally their job positions, which might mean that they will control what technology a company uses for their phone contracts, we're able to really delight these customers and give them what they like. And when you delight customers, it makes it much easier to do cross-selling to them as well. So we've shown you a couple of applications for today's demonstration. One was for network analysis, the other is for predictive churn. It will be great to get some additional data and be able to do some cross-selling recommendations as well, which is what some of our customers do. So for the telco space, they do more than just mobiles. Most telecommunication providers also do home broadband and TV packages and movies on demand. So being able to get those extra data sources and being able to combine those together to be able to make very powerful cross-selling solutions as well is some of the things that Actian Platform is fantastic at. The aim of today's presentation was really to take you on this journey. So we started off with some static reports, which was really just data that was inside of Hadoop, which was very hard to report on. There was no drill down whatsoever. And by being able to access that data, enrich it, and make it very easy for an analyst, as well as in a high-performance environment, we're able to go to that reactive reporting where we're doing our monitoring the data in near real time. It's alerting us and telling us what's happening. The next part of our demonstration, we've shown you how by combining more data sources, more relevant data sources, and looking at all of the data, we're able to do better proactive analysis and be able to predict what's going to happen next better. And the stories that we've talked to you about today are really how these solutions were embedded into the business processes to make them analytics driven and really make, throughout the organisation, their business processes, everything they do, be done on smarter decisions. So look, that's it for today's webinar. So if you do have any further questions, you have our details there on the screen. It's been a pleasure to be able to show you this. It's great to be able to talk about customer stories and really get into what value it's adding and how it's making a difference. So if you do need anything else, please let us know. And we'd like to thank you once again for your time.
Thanks a lot.
Bye for now.